Hello, I want to talk to you about this system here that we have. Basically, we have a mass M1 here, this mass M1, another pulley with a mass M, and we have here a mass M2. And basically, we want to present a way to solve for this type of uh, of systems, which we find is a lot easy and it makes the calculation much faster. We assume that this system is rotating this way, basically, and it is rotating with an acceleration A. And we try to find what is the acceleration, let's say for M1, what is the acceleration for M2, and what is the rotational acceleration. So uh, we put here the equations to remember, which is basically the force equal mass times gravity, and we have also the torque equals ICM equal ACM, which is basically the inertia of the disk times the angular acceleration, and we have here also the inertia of this pulley, here, M, and basically it equals half of the mass times the radius squared, and also I added here what is the inertia, which is equal the inertia of an object which is rotating at a distance of the center of mass, which will be ICM equal M times the distance squared, which is the distance of the center of mass. And I'm going to add here another equation, which is I equal the M times D squared, which is basically if we have a point mass which is rotating around a point which is at a distance d, and it has a mass m. The inertia of this rotation is of the mass m is m times d squared. Okay, so we assume we have an angle theta. Basically here we have m1 times g, we have m2 times g, and really those are really the two forces which are acting on this system here. Of course, we have here like the normal force, which is acting this way. It cancels the weight, which is acting this way, but it's not contributing to the acceleration. So basically we have here a force M1, G sine theta, and we have here M2 times G, and we're trying to solve what is the acceleration of this system. Okay. Of course, if you look at all the internal forces, there is also tension here on the ropes, etc. But we really have to make all the calculation with all the forces, and that becomes difficult. But you can do it. But this is I find a quick way to make this type of to find the acceleration. Basically, what we model is like this rope here what it does, it will bring the mass M1 here. It becomes a point mass, which is at a radius r, and M2 will become here as a point mass M2 at a radius r, and the forces acting on it will be here M1 G sine theta, and here we have it will be another force acting this way, which is M2 G sine theta. Okay, so all we have, the system becomes here, this is our pulley, this is the radius r, we have M1, M2, and we have here M2 times G, and we have here M1 G sine theta. Okay, so we can move to the next slide. So all our system becomes a mass M2 mass m1, we have a force here, m1 g sine theta, and here m2 g, and we have a radius r and a pulley of mass m. Okay, so for the system to work, to calculate the system, we need here to find what is the total force acting on it this way, F, and what is the inertia I of the whole system of mass m1, m2, and m. And basically we have T, which is the torque, equal F times R, and really the forces here acting at the distance is basically m1 sine theta minus m2 times g. Okay, that's the torque. And I, which is the inertia, becomes half of m r squared, which is the inertia of the disk or the pulley, plus m1, which is at distance r squared, plus m2, which is at distance r squared. Okay, and we can factorize here. Basically it becomes half of m plus m1 plus m2 at a distance r squared times r squared. And we know that T, the torque, equal ACM, which is the acceleration times the inertia. So if you want to solve for ICM, equals T divided by I. So if we have to divide T, which is this one, by I, which is this one. Okay, and we forget here to put a factor of R. Okay, so there is an R that will cancel out. So basically we have m1 sine theta minus m2 divided by half of m plus m1 plus m2 times r. Okay, now if this is the angular velocity, it's basically that this is, if this disk is rotating this way, it will be accelerating this way, angular acceleration. And if we want, let's say m2, which is down here, at what is the acceleration, m2 and m1 will have the same acceleration, then we need to multiply it. We need to multiply the acceleration of the masses m1 plus 2. We need to take ACM and multiply that by r. Okay, ACM multiplied by r will give us m1 sine theta minus m2 divided by half of m plus m1 plus m2. And this is really the formula for the acceleration of m1, m2. Okay, so that's what we wanted to show, how to find the acceleration of such a system in a quick way that you can do it in a few equations.